what we typically do is what we say when we talk about ourselves is that we're on a quest to make numeric time series data searchable. And what we mean is we're building tools that allow someone to use a graph itself and the data underneath it as a search query instead of having to understand how to program what you're looking for in a time series of data. You choose a graph itself as that query, and we find it across a very huge range of data. Most of our work has been developed around the financial data, where you choose a graph or a chart of, say, a price pattern within Apple, a price pattern within interest rates, and a price pattern in housing starts. And you want to know, when has the world looked like this previously, and what tends to happen next in the price of Apple. That's currently how we work, and I'll just show, I guess, a little bit of our interaction. If you take a pattern in Apple, in Apple's price, you have something that you think is somewhat unique, and you use that directly as a query to find similar instances where you have kind of this more or less, in this case, what we're looking for, or what we're considering similar, is highly correlated. And obviously you can calculate numbers of different types of data features that you might think are related, like volatility, magnitude of changes, different spikes, whatever the features are, we can sort of customize search. It's taking a little bit. There we go. So we have another, in that instance we go across the entire S&P 500, and we found a match in Torchmark Corporation from 94 to 95 with a score that's in this case based on correlation of 0.89.
Can we see it?
Yeah, so you can visually inspect the different patterns. And so it's an easy place to start. In addition, the data is rapidly available. There's a number of data vendors. So when you're just getting going, you restrict your domain to something that you feel like you can get a hold of. But health data is also extremely interesting because of this concept of search by example, where you may not know exactly how to describe what's going on in the underlying data for, say, a patient. But if a patient is being described by a distinct set of data, such as maybe their EEG, their heart rate, their temperature change over time, there's a lot of numeric time series data that would be extremely interesting. And if you had the concept of, I mean, obviously you could go to the macabre and say a patient who passes away, maybe we'll stick to the sunnier side, and we'll say a patient who gets well after a drug treatment, and you want to find other patients who look similar to that patient. One way to do that would be sort of creating an environment defined by the data and using that environment as a search query, maybe across a huge number of patient data, to find another potential patient who would respond similarly to the treatment that you administered. And so when Nagel suggested that we present, I think there could be a lot of cool applications within health data. And so I'm not as familiar with this realm, which is a little bit why we wanted to just sort of put this out here. And you can upload your own data, and we can talk about it afterwards, how that might look. But you can make any data searchable. And so he put out a little bit of a call to the listserv to see who might have a data set that I could incorporate. And I just wanted to say a quick shout out to Zio for providing some health data so that I could analyze it and have some results. And so I didn't have a ton of time to kind of get familiar with the data, and there was some manipulation that I had to do. But I decided to ask two kind of distinct questions and then see what kind of answers I could get when I analyzed it using the concept of time series data mining. And the first one was, when I have had a similar sleep pattern to the one that I experienced last night, when in the past have I slept like I slept last night? And this one is somewhat personal. When you wake up and you've had a nice night's sleep, I mean, you feel like $1 million. And if there was something that I could do to try and set myself up, whether it's working out the day before or eating something in particular the night or the day before, that would set me up to sleep particularly well, it would be interesting to know that. And so one of the cool things that Zio does is they provide a pattern for all the different nights. So each of these is 1 night of sleep, and it's measured on a scale of 0 to 4. I think 4 is heavy sleep, 3 is REM sleep. Suggested that you felt more refreshed when you wake up in the morning.
Wow.
In this case, we'll take.
Is this your data?
So no, this was sample data from Zio of I think a 35-year-old male who had measured himself over 360 days. And so I took 100 of those days and transformed it into a way that we could upload it into the system and make it searchable.
Do you guys have subjective reports also, like about how refreshed you felt afterwards, or?
We don't have that, although it has is it a Z-score that you guys attribute to each night?
So yeah, so we do have one single measure that sort of summarizes like sleep. There is some subjective data in there, but we didn't have a chance to get together beforehand.
Yeah, we didn't.
Is that based on this data? Like this, does that score take that as an input and then produces this Z-score? And does that correlate with subjective?
We've never tested it as such, but from what I know on objective sleep, probably.
So we're going to pretend that the Zio score may reflect how I felt in the morning, but maybe it didn't. And so maybe I think that this night it happens to have a very high Zio score, but if it didn't, we're going to pretend I felt especially refreshed. In this case, we're not just going to search for similarity based on correlation, because something that's correlated that moves between 2 and 3 would also be picked up, when in this case it's really those movements, the magnitude of the movements that are interesting, as well as the shape of the movements, if that makes sense. So we've changed the way we define similarity in this case. But using this 1 night as a search query, I'm just going to find every other night that was most similar. In this case, because of the way I had to manipulate the data, these start and end dates are meaningless. They're set up for financial data. But you could go through and analyze. Here is the query itself. In this case, in the sample of 100 that we looked at, this is the most closely correlated piece of data.
It actually has a very high correlation coefficient.
Yeah, this correlation also, because of the way that we're searching, is somewhat meaningless in this instance. But it's the closest of all of the data that we looked at. And so you get some of the same initial spikes. In this case, it looks like it's matching on a few of the movements. That one's not probably the closest. But you get some of the same starting pattern and some of the same general movement, especially I would say probably in the middle as you go through. And if we were to load up much more, in this case we loaded up 100 samples and looked at a period. The smaller the period that you examine, or the more data you search across, obviously the closer the matches that you find.
How close are the quality scores that you're actually getting on the basis of this correlation?
How close are the quality scores?
Well, yeah, you obviously have some correlation function to figure out how close the graph is.
Yeah.
I guess what you really want to find is you want to find a correlation that has a good link to the z-scores, or whatever we're pretending is the actual quality value here.
Right, exactly. And if we take taking one that had a high value, it was actually, I found better results taking one that had a low value. But part of that may be because we're looking at some of the same items, in the sense that length of and time spent in the different states are probably matched on both sets. We'll just check real fast.
Is there a way to use the correlation function itself as the variable thing that you're trying to optimize to match, to minimize, if you like,
yeah,
the difference? Yeah.
So finding the correlation. So in this case, let me restore this so that we can look at the actual correlation values. In this case, the most highly correlated is 0.781. We can take a look. It was also a pretty low. These are the first 3 matches. The first highest matches also have very low z-scores. And we can look at that correlation to get a sense of. And then it starts to fall apart a little bit. Although 61 is still a fairly low score in their case, and so correspondingly, you would expect to see it. There were a couple other ways that I thought about analyzing the sleep data. One that is to try and predict how much sleep you would get the next night if you knew a pattern of, if you knew your sleep pattern over the course of a set of nights. Could you predict how much sleep you would need the next night? So this data came from Daniel, who also responded to the request. In this case, we're looking at 700 data points where he tracked himself over the course of 2 years and the amount of sleep that he got each evening. With a number, you might think that, I mean, one could confuse this with him having an extremely active social life, but I think he probably just didn't track some of these periods as opposed to
too busy.
As opposed to staying out. But if we zoom into maybe what's somewhat of an extreme movement, in this case he's going from 400 days of, or 400 minutes of sleep to almost 560 minutes of sleep. And if we use this directly as a search query, we're going to find every other time when he has sort of the same general pattern. So here are the closest matches. Again, even, I don't know, this is a 10-day pattern across 700 data points. You don't actually have that many patterns that will be highly correlated. But then you can backtest. This is some of the analytics, and you can ask, in this case we go 1 data point forward. When Daniel exhibits this pattern, how much sleep does he generally need the next day? And as you might expect, he needs significantly less once he's had it. And so each of these is a matched, one of those matched patterns, taking the day after and seeing how much sleep he got the day after that pattern was matched.
Although, since there's probably like a range in which these numbers fall, right? Because he can't like sleep all day.
Right.
And I guess we're discounting when he sleeps 0. He doesn't go off to like negative numbers.
Right.
So if you choose something in like a higher part of the range, wouldn't that range affect like?
Yeah, you could explain it. I mean,
yeah.
I spent a little bit of time looking at this, and then I'll get to my last little piece that I analyzed. But the reason I didn't spend a ton of time is because everyone has weekly sleep patterns that you would expect. I mean, if you start on Monday, if this is a Monday, and this is a Saturday, I mean, that wouldn't work for this one, but you have natural cycles of sleep where once the weekend hits, you have much more. You wouldn't need a software to tell you something like that. Although you could have one. The final thing that I took a look at was in a period of, I didn't have time to pull this up beforehand, but in a period of declining, when the minutes that you slept changed, a question that I found a little bit more interesting is what tends to happen to the composition of your sleep. So if some percentage of your sleep is REM, some percentage of it is heavy, and some percentage of it is light, how would you expect it to change as the quantity of your sleep was changing? And in this case, it's especially well suited, I think, to time series data mining, because if you take one moment in time, it really probably depends on what you did the night before and the night before, what the composition of your sleep is going to be that night. And so what I did was I took a period where his sleep was declining over an 8-day period and used that as a search query. I exported all of those results and then looked at, in the same period, because the ZEO tracks the percentage of data, or the percentage of sleep that the percentage of time you spend in REM sleep in the night. And I compared during each of those periods where you have a declining, 8 days of declining sleep time, what happened to REM as a percentage of your total sleep. And as you might expect, his sleep was essentially getting more efficient. I took the top 10 answers. It's not a statistically significant study. If you had significantly more data, you could do some pretty cool analysis, I think, where you examine some questions like that and find that as he's having less sleep over the course of the night, essentially his, maybe sleep efficiency is getting higher. And so the idea is when you have so much data, how can you mine it and learn from it intelligently without having to necessarily know how to data program and ask those questions in a really sophisticated way? Or would there be some ways that you could play around with the data before you would devote the energy to program the data questions? And with the idea that at some point, coming back to that concept of a patient who's defined by a set of pieces of data, using that patient directly as a query to find similar patients who might react similarly. It's kind of the direction at some point we hope to be at. But anyway, thanks a lot, and I think at this point, open it for questions, or I don't know how much time there is.
Yeah, questions. So, one question that I wanted to start out with actually was, do you have a sense for what data streams would be ideal for you to be working with from a health perspective?
Yeah.
Can everyone hear the question I just asked? I don't know if you want to say it back to the audience.
What sort of data streams would be ideal at looking at from a health perspective? So, yeah.
Yeah, that's.
Anything that is captured consistently over time. Obviously, the whole system is set up right now to work with financial time series data. It happens to also work well with any sort of, it lends itself to any sort of time series. But when it has the more broken the time series is, it's a little bit harder to identify good patterns within that, because you pick up the extreme drops as correlations that you probably wouldn't want to pick up. But anything, so sleep data, heart rate data, are technical.
ICU?
What's that?
Have you considered ICU?
No, ICU, like.
Yeah, no, I was just really interested in this because like my company is doing a lot of data gathering in ICUs.
Okay.
I think it's the analytics and the predictive analysis for how it's going to impact like healthcare outcomes.
Sure.
Still like a key component that's missing. Like right along those lines of predictive analysis based on data, right?
Yeah, exactly. So that would be great. I'm not as familiar with even the type of data that's collected. I know Stephen, who's one of my colleagues, he has the technical background, and he had looked previously. There's been a lot of work done in EEG pattern recognition and associating EEG patterns with strokes or different states of the person's being, and using some, not just looking in that case at. Obviously, you wouldn't look at correlation, but you can define the features that you want to recognize, as I was saying earlier, like volatility, different spikes in movement that I think could lend themselves a little bit better to that. But we should talk and see what sort of data is there. Yeah.
I wanted to ask also, is this available to the public, or like as a service, or is this solely focused at financial institutions?
Really, right now it's solely focused at financial institutions, but if anyone is interested and you want to talk to me, we can set up an account and I can show you how to load data and make it searchable, and you can just play around at your heart's content. I don't know how much financial data that we can deliver you without signing up for a license, but I'm happy to do that because we're just interested in seeing how people would use it outside of the domain that we're familiar with. Yeah.
Well, to follow on his question, how are you set up to handle multivariate data? Because the ICU is going to give you things like temperature, heart rate, respiratory rate, pH values, a whole host of things that certainly vary over time, but you need to look at multiple correlations at the same time.
Yeah, we can, for anyone who's interested, we could take a look afterwards. The same is true within financial data. Right now it's not set up within our upload system to be able to handle a query of like 6 or 8 different things moving at the same time, but that's where we are with finance. And then it's sort of a question, what we would need to understand, or what one needs to build an understanding of, is which are the most important, which are secondary. How would you weight, if you've got 6 things that you're trying to match on as far as correlation, how do you weight the interaction between them as far as which is most important, which is second most important? But we're going through that process right now with financial data, because it's really an environment that you want to recreate. It's not, I mean, some people associate movement in one indicator as being sufficient, but most people want to look at 6 or 7 things together and find those matches.
So one thing you might, if you're looking for applications,
yeah.
I was thinking about your mobile device. So diabetic patients who are sticking themselves all the time to do their blood glucose measures, smoking cessation and things like that, behavioral triggers for those, anything where the tough part will be finding the continuous data, except
right.
maybe in the ICU or someplace, right? Because people have to be hooked up to a monitor or something like that. But I would think it'd be very interesting to lock into existing data sources like the weather, other types of things, if you're looking at seasonal allergies or environmental context, right? So that data is out there, right? You just have to tap into it, and then add that personal data in. I guess my question is the business issue you're trying to solve. So first application looked like you were trying to find a success story, right, or a prototype, and then go out and find other so I've defined this as, here are a set of conditions I believe create a desirable outcome.
Yeah.
Can I go out and find other patients and target them to prevent, a disaster or something bad happening?
Sure.
Right? That sounded like one application. I guess the other question I have is along the lines of the multivariate. So a lot of the data is noisy and is, especially the streams of data. So there's a lot of these electronic medical records and things like that.
Right.
They're kind of choppy, right? So they are event driven. Mm-hmm. So every time you get sick, you go to claim, it goes through the system, blah, blah, blah. It's not really continuous in like a sleep pattern type thing. Right. So it may not be as, your application might not be as useful for something like that, where you're just looking at this massive
definitely
data.
If you're just trying to screen, there's many better applications. But if you're trying to do something where you're looking at the rates of change over time or distinct patterns, then hopefully we'd be able to find some way to look at.
And your algorithm can parse out trend versus noise and look for.
I mean, we'd have to look at the data. I mean, the big question is whether, when you use one example as a search query, how close is that to what someone would have expected to see when they're doing the search? Because in the case of financial data, there are no great ways to search back across and find patterns. So even when there is a lot of noise, say in daily variation, as long as it's showing the general trend, people think that's a match. But then, as you get into a new domain like healthcare, you would have to work with people who are experts.
So I'll stop with this last one. Yeah. So what I was thinking of is, if you can define success, then work backwards with a set of variables and find the conditions that preceded success. Right? What's the context in which that defines that success? And the other part would be very interesting is to look at matched success, not success, and parse out the differences.
See which variables seem to be different.
That would be very useful.